Hey guys, today we're doing variables on both sides. So we're just going to be adding to 3.1, which was multi-step equations. We're just going to make them look a little bit scarier, but I promise it is the same thing, okay? So that's what I mean by a little scarier. They get a bit longer, but I promise it ends up the same way. So let's just get right into it today. To solve an equation with variables on both sides, we need to use inverse operations. To collect the variable terms. Remember, variable is with a letter. A variable is a letter. So all of our terms that have a letter on one side of the equation, and the constant terms, so the terms that don't have a variable, don't have an X or Z or whatever letter, no letters, on the other side. So our goal is always going to be variables equals constants. Then solve. Okay? So my job is to get all the variables on one side and all the constants on the other and solve. And here is how we do it. Notice we're going to have lots of similarities from 3.1 because a lot of the steps are very much the same. Okay? Step 1 is distribute. If you have parentheses, first thing you're going to do is distribute. Okay? So I've got a negative 10x plus 3 times 3 is 9x. 3 times 4 is 12 plus 1 equals negative 3 times 7 is negative 21x. Negative 3 times positive 3 is negative 9. Okay. Step 2. So that was step 1. Step 2 is combine like terms. So I see I've got 2x terms, and I've got 2 not x terms over here. I need to squish them together. Notice I'm staying on one side of the equal sign. Okay, I can't squish them together on other sides of the equal sign until I do inverse operations. So if I'm just squishing together, I have to stay on my side of the equal sign. So I've got negative 10x plus 9. That's going to be negative 1x. I'm going to put it over here though. 12 plus 1 is going to be 13. Notice I had an x term and a not x term over here. So I can't squish anything together. I can't combine like terms on this side because they're as squished as they can be. So that's step 2. Combine like terms. Now step 3. Here's where we differ a little bit from 3.1 because we have x's on both sides now. Okay. I need to move the variable terms to the same side. So I'm going to add 21x to both sides. I'm doing that because the 21 is negative. That cancels out my 21s on my right side. And over here on the left, I've got 20x plus 13 equals now a lone negative 9. Okay. Step 4 is I need to move the constant term. So notice I put the x's on my left side. That means I need to move this 13. Because if I move the 9 over here, then I'll have everything on the same side, which is not what I wanted. Remember, I wanted variables equals constants. So I want all my x terms over here. I want all my constant terms over here. So plus 13, that means I'm going to inverse that. I'm going to subtract 13. Cancels out. I've got 20x equals negative 9 minus 13 is negative 22. That's step 4. So notice now I have variable terms and not variable terms. Variables equals constants. That's what I wanted. After this, I'm at step 5, which is my then solve step. I need to get the variable all alone. So now I'm looking at the x and the 20, and in between there is a little multiply. I undo multiplication by dividing. So I'm going to have x all alone equals negative 22 over 20 would simplify to negative 11 over 10. Fractions are okay. That would be my answer. Okay. Negative 11 over 10 is what I would put into delta math. All right, let's practice one more time. This is what your homework looks like, a little bit nicer, right? I need to move all the variables over here, and I need to move all the constants over here. So I'm going to do minus 7x on both sides. Notice I'm lining the x's up together. Please do that every single time. Remember, I can't squish these together, so I'm not going to bother trying. The x's are always going to line up, and then my constants are always going to line up. So I've got 2 minus 7 is negative 5x plus 9 equals negative 26. Now I'm going to subtract 9 from both sides because I'm adding 9 here, so I'm trying to get rid of it. And I've got negative 5x equals negative 26 minus 9 would be negative 35. I'll divide by negative 5 on both sides because now I'm trying to get x by itself. Negative 5's cancel out. I've got x equals 7. And that's what I put in a delta math. Okay. Once we get multi-step equations down with variables on both sides, we now care about the number of solutions that a question can have. So, the solution of an equation is the value or values of the variable that make an equation true. For example, 5 equals 6. 5 does not equal 6. But like 4 equals 4, if I held up 4 fingers on both hands, it would look the same, right? I'd be holding up the same amount of fingers on both sides. 4 equals 4 is a true statement. That's what I'm trying to get, okay? Equations with one variable, meaning one letter. So there's 3 x's, but there's only x's, not x's and y's. That's what I mean by one variable. Only one type of letter. Equations can have one solution, infinite solutions, or no solution. And you have to look at your homework and solve the equations and then say how many solutions they have. So here we go. My steps on the other page were distribute. So I've got 5x plus 4 equals 4x minus 24. Now I'm going to move the x's to my left and move the 4 to my right. And I'm going to get minus 4x on both sides, minus 4. So now I'm doing, if we went back up here, I'm doing step 3 and 4 at the same time. I can totally do that. It just saves us a little bit of time. So what I'm doing is I'm moving the x terms to the left and I'm moving the constant terms to the right, and I get 1x equals negative 28. 1x is what I'm trying to get to. Like, that's just x, okay? When I get x equals something, notice I said something, not some things. That's one solution. I know the solution is negative 28, but that's one number. So when I get x equals something, my equation has one solution. Okay? So that is what it looks like. Let's write that down. One solution always has x equals a number. Okay. Let's do it again. I'm going to distribute and combine like terms. So I've got 8x minus 4 equals, I see a 3x and a 5x. That's going to be 8x minus 5. Again, I'm going to move the variables over to the left and the constants over to the right. So I'm going to do minus 8x on both sides plus 4 on both sides. My 8x's all become zeros, and I am left with 0 equals negative 5 plus 4 is negative 1. Okay, we have to ask ourselves, does 0 equal negative 1? No, they're different numbers. So when I get an untrue statement, that is the same as no solution, or 0 solutions. Okay, my last one you guys can guess will probably be the infinite that we talked about. Let's see what it looks like. 4 times 2x equals 8x, minus 4 times 1 is 4. 2x plus 6x is going to be 8x. I'm going to drop down the minus 4. Again, I'm going to subtract 8x from both sides and add 4 to both sides. And what I end up getting is 0 equals 0. That's a true statement. 0 does equal 0. But that's so profound. Okay? When we get 0 equals 0, that is infinite solutions. Or we could have known that this was infinite solutions pretty early on. Do you see how on both sides of the equal sign, I'll use a different color. On both sides of the equal sign, I had 8x minus 4. Okay. When I have matching, that's called an expression. When I have matching sides like this, that's a dead giveaway that also means infinite solutions. So we can drop it all the way down to 0 equals 0 and know that it's infinite, or we can catch it pretty early and we can say, hey, it's the same on both sides. That's infinite. Okay? And here is what that section of your homework looks like. So we're going to do this first one together, and then you're going to do the other two. I've got to distribute on both sides, and then I'm going to have to combine like terms. So I've got 5 minus 10x minus 18 equals 9x plus 32x. I'm doing this really fast because your calculator can do this for you. Okay? Minus 20. Now I'm going to combine like terms. 5 minus 18 is negative 13 minus 10x equals 9x plus 32x is going to be 41x minus 20. Now I need to move my x is over here, and my not x is over here. So I'm going to do minus 41x minus 41x. Notice I put it under the x's. I almost messed that up. So I've got negative 51x, negative 13. I'm just dropping that down and just dropping down the negative 20. And I'm going to add 13 to both sides. I've got negative 51x equals negative 7. And now I need to solve. So divide negative 51 on both sides. Cancels out. I have x equals, the two negatives will cancel out, 7 over 51. You can find that in a decimal, then that's cool. I recommend leaving it as a fraction. So we're going to put in here, we're going to say this equation has one solution. It is one solution because I got x equals something. Okay, I didn't get an untrue statement like 0 equals 1. I didn't get the same thing on both sides of the equation. I got x equals an ugly something, right? Weird looking fraction, but nonetheless I got x equals something. So I'm going to say the equation has one solution, and then Delta Math is going to say, okay, what was that one solution? And you're going to put x equals 7 over 51. Okay. Try it out on your own. I want to see the work, but this one's going to be infinite solutions. And this one is going to be 0 solutions. Show the work and show me why. Okay? Email me if you have any questions. Thank you.